There are three ways to solve quadratics, one with factoring, the second one with completing the square, and today we are going to look at the quadratic formula. Before we can do the quadratic formula, we have to recognize standard form as y equals ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is our constant. Okay, when you know that standard form is ax squared plus bx plus c, then you can use those coefficients to plug into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. It is also important to remember that b squared minus 4ac, that is here underneath our radical, is called the discriminant. Remember that the discriminant tells you how many and what kind of solutions you are going to have. Okay, if b squared minus 4ac is a positive number, which means that it's greater than 0, then you're going to have two real solutions, because when you take the square root of a positive number, you get two solutions. If b squared minus 4ac equals 0, then you're going to have one solution, which is just the vertex. You will have only that one solution. If b squared minus 4ac is less than 0, which means it's negative, that means you have a negative underneath the radical, which means that you will have two imaginary solutions. When we look at this quadratic equation, x squared minus 4x minus 5 equals 0, the first thing we need to do is to make sure it's set equal to 0, which it is, and then we need to identify a, b, and c. In this case, our leading coefficient, a, is 1, so we have a equals 1, b equals negative 4, and c equals negative 5. Now we're going to use the quadratic formula and plug these numbers in to find our solutions, or our x-intercepts. Okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's get started. If b is negative 4, then negative b must be positive 4. Plus or minus the square root of b squared minus 4ac. That means negative 4 squared minus 4 times 1 times negative 5. And all that is over 2 times 1. So you end up with 4 plus or minus the square root of 36 over 2. Well, the square root of 36 is 6, so you get that x equals 4 plus or minus 6 over 2. So you have x equals 4 plus 6 is 10, divided by 2 is 5. 4 minus 6 is negative 2, divided by 2 is negative 1. So those are your x-intercepts, those are your solutions. Remember, solutions, zeros, are x-intercepts, so you would expect this parabola to cross the x-axis at positive 5 and at negative 1, and to be sketched something like this. You end up with 4 plus or minus the square root of 36 over 2. Well, we know that the square root of 36 is 6, so we have 4 plus or minus 6 over 2. So you have x equals 4 plus 6 is 10, divided by 2 is 5. And then we'll go 4 minus 6 is negative 2, divided by 2 is negative 1. Remember that our solutions are x-intercepts, so if we were going to graph this or sketch a really rough graph, we would expect to have x-intercepts at positive 5 and at negative 1, and you would expect for a parabola something like this to come up on the screen of your calculator. Let's look at one more example. We said that these equations needed to be set equal to 0 before that we could go on with the quadratic formula. Here our equation is equal to 15, so we need to move the negative 15 back across, so we would have x squared plus 6x plus 15 equals 0. Okay, so here a equals 1, b equals 6, and c equals 15. So now we're back to putting this in the quadratic formula. Negative. So we have that x equals negative 6 plus or minus a square root of negative 24 over 2. Now when you have a negative underneath the radical, you need to remember that that's going to be imaginary. You have to pull out the I. So you have negative 6 plus or minus I times the square root of 24 over 2. The 24 needs to be rationalized. We know that 24 is actually 4 times 6, and the square root of 4 is 2. So we can say negative 6 plus or minus the square root of 4 is 2, so we're going to have 2i, and the 6 stays underneath the radical, and all that is over 2. Now because this 6 right here, and this 2 and this 2 all reduced by 2, we'll reduce that to negative 3 plus or minus I times the square root of 6, and that is the final answer.